Hi, I'm Paul Hopewell. Welcome back to my workshop. Around July 2021 I shared with you a video of a failed drill sharpener. A failure not because the sharpened drills wouldn't cut, but because the drill web angle was excessive. My latest creation is more successful. In the next two videos I'm going to show you what I went through to make it happen. This drill sharpener is going to be built using some of the parts from the original drill sharpener to save both on time and materials. It's a good job I did because this project took me 4.5 months to make. I'd like to explain a couple of things at this point in the video, that while the drawings I have created were done using a CAD program, issues kept arising that meant changes were made as I went along. As we all know, if you change one thing, it can affect other components along the line. I ended up with 13 or so drawings when I first drew the plans for this version. I also altered almost every one, some more than once. You'll see this during the videos. My plan was to use a multi-staged approach to cutting the drills instead of the single hand-wound system. In this drawing you'll see only 3 handles, but I did eventually end up with 4. Like its predecessor, the drill center line is 59 degrees from the hinged axis. But this time the drill is presented to the cutting wheel on, inside or beyond the pivot point, ensuring that I get a full range of relief options. I originally thought about using a ball and spring interlock here, but I decided it wouldn't work for this application. One handle operates a cam and link system on the left. That allows the drill to be moved away from the cutting wheel while it's rotated 180 degrees to evenly cut the second face. Not shown here is another lever. It's the interlock. It frees the drill, enabling it to be rotated about its axis. Disengaging the interlock allows the ratchet lever on the right to rotate the drill until the interlock re-engages. Then the cam handle on the left is reset to the starting position and the next cutting session starts. The last lever, center top, is used to create the drill bit's relief angle by pressing it downwards. This bit of angle was part of an old window lintel. It's 100 by 100 by 6 millimeters, 4 inch by 1/4 inch. It's too big for my bandsaw, but with a bit of wiggling I managed it. This angle plate is going to be used for the support plate and the side plate. The problem is that it's not big enough on one side to do the job, so I'm going to hack a bit off here and there and weld it on to make up for the missing height. No, this isn't a glue stick. The marks are to help me line up during the welding process. It might look like I'm forcing the bandsaw through the workpiece, but I am actually holding the blade off to prevent breakage. I used an angle grinder to remove the center section from this part. I also used it to clean up and fettle after welding. The angle grinder also came in useful for cutting these 2 arms from this 12mm thick scrap plate. I blued both arms and scored the spines on each to check that I had enough material to clean up. Then I rough measured the material that was to become the base plate. After cutting the base plate off, I welded the hole up and dressed it all off with the angle grinder. This 12mm plate needed to be 100mm wide by 310mm long, so I blued it and scratched one side just to confirm I hadn't overcooked it with the angle grinder. It was close. This side plate had also been given an extension. This also needed to be checked. It needed to be 130 plus 1mm to allow for cleaning on the bottom face. This plate supports the cutting head and it's also mobile about a pivot bolt on one corner. It is also a bit bent where the extension was added, as you can see here. It doesn't matter because both uprights are bent about the same amount. It's time to scratch proof the support plate, and after a couple of scratching sessions I found the best position to complete the layout lines. The first of many alterations was added in here. It was a radius, the first of two on this plate. The underside of this support plate was cleaned with a stone, after I'd cleaned it with the angle grinder. Despite it looking like a ploughed field, it will do. After all, it'll look as bad as that after a few sessions of cleaning up a few drill bits. These radiuses are going to be cut in using the angle grinder later. Before I get going on any machine, I like to treat all faces with a coating of slide oil before oiling the slide faces. After cleaning the milling table down, I started the complex procedure of milling all edges around the support plate. I say complicated, I mean the process of holding the work. The noise wasn't as bad as I thought it might have been. To cut out this recess, I simply set the cutter over the inside corners and made note of the handwheel positions and plunged through. The rest of the inside cleaned up to the 2 plunge settings. Cleaning up the ends on the bottom face was an altogether much quieter affair. This is the only video I've got of me grinding the external radiuses on this support plate. I was thinking of playing a bit of cha-cha-cha music in the background for this. This side plate is also going to be modified later in the next video, but for now I used the set square initially to set the base to the table, but because I hadn't much material to play with, I set it to the scribe block on its best side with the intention of taking only a skim from this edge. It isn't necessary to get this side parallel to the previous one, but why not? Using 3 sets of parallels saved me from having to swap stuff about just to do one operation differently. With this side plate sat on a parallel, I skimmed the top edge down to the scribe mark. This left me about 1 mm to skim off the bottom face. After setting 1 milling vise true, I used a section of bar to set the slightly smaller vise to line up. Using the scribe block, I set the arms level, skimming the top edge and one end on each to aid the marking out process. Laying out the markings for each of these arms is quite a time-consuming process. Before committing these arms to the milling machine for the initial roughing process, I went through the process of checking and double checking before I dare commit. You can see here that the roughing operation appears to show that a lot of material had to be removed. While doing this roughing operation, working the hand wheels was a bit like holding a helicopter in a smooth hover on a gusty day. I was a bit cautious here because I'm using a medium length tool whilst the quill was at mid-reach. I've had cutting tools grab and break before now, and it ain't funny dodging a broken tool after it's hit you. As you can see here, the arms are only roughed out at this stage. The finishing stage is pretty much the same process as the roughing stage, except that parallels were used to maintain parallel faces, and the only thing here I didn't show was how I drilled the pivot hole. While I'm on the milling machine, I skimmed up the first edge of the base plate to clean up, using 2 milling clamps and a couple of G clamps against an angle plate. After fettling the first edge, I placed this edge onto two parallels and reclamped to finish to the overall width of 100mm. The two ends are then cleaned up square to these edges using T-slot stops. The plate was clamped down onto a couple of 2mm thick spacers before milling each end in turn. This is where I make a couple of pivot tubes. They are to be 12mm diameter and 22.5mm long, with a tiny bit at each end for adjustment if need be. After machining the first end of these two pivot bushes, I blued the second end and scribed to length. I finished the face leaving about 0.5mm on the end just in case. It's time to weld these pivots onto the support plate, but I need them to be in line with each other. The bores were 5.7mm diameter and the only material I had was a good length of 6mm threaded rod. As you can imagine, it was just a little bit too big to fit the two pivots, so I machined the rod to fit them. You can see that I've rounded off the pivot end of each arm, and the two pivot tubes on top of the support plate have been treated to a good thrashing on the belt sander, hence their appearance. This is where I stripped the finished sharpener down again to replace a little bit of video I've misplaced. I did this to show you how I final drilled and reamed the holes on each side to line up with each other. Although this bit of video is not necessarily in sequence, it also shows you the two arms and how they were machined in line with each other. First things first, I cut the head off a long 12mm bolt and turned a cone on the end. This was screwed into a bit of scrap and clamped to the table. It was then in turn set in position directly below the milling head using a DTI. The cone was also set high enough to allow the support plate to be mounted the other way up. For display purposes only, I'm using a smaller reamer to prevent damaging the already finished bore. Originally I placed a well-fitting bolt here to help support the bottom end. That's to help make the first cut. Then I used a magnet at the top to stop the top wandering off. I also used a cap head screw like a jack to support the back end of the tube assembly. Originally the temporary fitted bolt didn't allow this assembly to wobble about quite so much as you see here. With everything in place, the first pair of reamed holes were finished. Then the support plate was turned over and the other end was completed pretty much on using the same setting, except that I needed a long reach reamer to complete the process, but I hadn't got one. I could only do it by pre-drilling both assemblies, and after reaming the support plate and a tiny bit of the drill carriage assembly, I was left with a small indent in the short arm of the carriage assembly to use as a reamer guide. I reamed the last hole on the drill carriage assembly like this, by allowing the reamer to pick up on the pre-reamed indent. With a few well-placed jacks and a G-clamp, the reaming process was completed for both assemblies. Long-winded, I know, but it was cheaper than buying a long-reach reamer. Right, on the drawing I'd included a spring and a thrust bearing, but I've now decided to just use a retaining ring. For this retaining ring I'm using one of the old Mark 1 cams by machining the cam off. I know it's a bit brutal considering the amount of time I spent making it, but it's no use to me now, so why not? It's time to make 2 rings to fit over the 50mm collar. I filched one from my battery stand counterweights for this job. It's all I've got that was big enough externally. Anyway, after skimming the front face a couple of times, I set about centering it. Then with a pilot drill to start, I gradually increased the size enough to get a boring bar in there. This material was a bit gummy to machine, but after showing it who was boss and who's got the spare inserts, I managed to rough the OD. Then I got cracking with the boring bar. All the dimensions at this point are roughed out. Now, parting the useful material away from the bit that's still in the jaws raised the pucker factor a couple of notches when I put the parting blade on the tool post. Well, it survived in one cut. It was only because it was doused in paraffin, but so too was the camera. At 80mm opening, one of the jaws needs about a 2 thou packing in to get it somewhere near true. Now that I've got everything how I want it, it was quickly completely finished. The other collar is the original one from the Mark 1, but again, like the retaining ring, I machined the cam face off and cleaned it up. This bit of spare material was only just externally smaller than the 2 rings I've just finished, but it's perfect for the ratchet ring. This ring is the one that will eventually aid the drill to be rotated about its axis. After the usual drilling and boring operations, this material was turned around to allow the back of the face to be machined to length. This part was also bored out to fit on the outer collar. The cam link, as you can very well see, is to all intents and purposes a curved rod. Its job is to turn a rotary motion into a linear one, to help retract and reposition the drill bit against the cutting face. It could have just been a straight bar with a couple of ball joints, one on each end. But I chose to make a simple job into a bugger of a job, so here goes. I still use a pointer made from an old drill bit in the milling machine to set things as true as I can. That reminds me, I must make a wiggler one day. Anyway, the holes are drilled just shy of the finished size so they can be reamed out later. Then I set the index table on the milling machine to start the milling process, but first I had to set it up to stay put when I start cutting. I chose to clamp the part directly to the index table for maximum stability. Using a 6mm 2 flute cutter, I set the table at no particular position to plunge cut a few holes down to about 0.5 mm from the index table face. Then, after satisfying myself that the cutter should be able to sweep across the arc, I set the index table locks to provide a degree of friction rather than to lock the table. This allows me to drive the material over the cutter without it bouncing about all over the place. The same procedure was roughly followed along the outside edge. The way I machined the 2mm relief below the top face was to set the tool to cut 1mm deep and then waggled the hand wheels all over the place to get rid of most of the material within the two marked areas. Then I did it once more to the finished depth. And there you have it, something resembling the cartoon character Sid from the Ice Age cartoon. Turning it over and reclamping it once more onto the dividing head table provided me a few more minutes of hand wheel waggling to get the middle of the link to show itself. Now it's beginning to resemble Johnny 5. Rather than muck about with another setup on the index table, I removed the excess material with a pedestal grinder and a belt sander, then spent 5 minutes trying to burn my fingers on the finishing sander. Having done that, I had one small detail to deal with, and that was to tidy up the 2mm recesses on both sides. The way I did that was to put a bolt through one of the two holes and lock it down with a nut. The other hole I simply put a bolt through it. By putting a loose bolt in the lathe jaws and nipping them up, the link will be centrally held on the lathe, and the fixed bolt becomes the driver against one of the jaws. However, you'll notice an elastic band around the jaws. This isn't to put more tension on the jaws, it's to stop the blooming thing clicking and clacking as it's being cut. Remember, the bolt held by the jaws hasn't got a locking nut on it. The reason for putting the link in the lathe was to remove as much of the rough sharp edges in the recess as possible before filing it to hopefully get it to look like a cast component. Don't ask me why, it just seemed like a good idea at the time. The cam was formed from a bit of 40mm round bar and then it was turned to length. This component was originally supposed to be 30mm diameter, and indeed I did make one, only to find that the link movement was quite well restricted. I scribed a line through the centre to confirm the centre height, then scribed a line 1.5mm above it, representing one of the internal slot faces. The other inside face is 16 degrees offset to this face, and it is to be 1.5mm below the centre line. I firstly rotated the cam in the right direction, then set my protractor to 16 degrees. After lowering the scribe block 1.5mm below the centre line, I scribed another mark across the cam. When I set the cam in the mill, I'll need these two lines to aid the setup, but I will still spot each line to prevent me getting carried away during the milling process. These two marks on the outside circumference of the cam represent the edge of the slot. The layout lines for the slot width and height are also needed. I used the scribe block again to complete these lines before spotting them in. The slot is going to be milled out in two sessions. Slot 1 will follow the line that's above the centre line. Slot 2 will follow the line below the centre line that's 16 degrees offset to the first. I'm using the milling vise as the setting fixture to get both of these slots correct. The 4 flute cutter I'm using is 1mm smaller than the required size. When the cut gets to depth, I'll move the cutter side to side to the finished size. Now for the second offset cut. Making sure that the scribe line is true to the vice jaw. This cut is offset to the centre of the cam and it terminates inside the centre hole, so I had to be careful not to dig into the centre. From one side of this cam face there are to be 2 holes drilled in. One is a through hole and the other is a blind hole. The blind hole, although I altered its size for a stronger spring, I eventually found that I didn't need it. The through hole was reamed out to 6mm, so was the now redundant blind hole. Now all I had to do was pop in a 6mm threaded hole in the side for a handle to be fitted. After a bit of a clean up and a little final fettling, the cam's finished. With the support plate on top of the base plate, I had decided to change something else. The cam was going to move the support plate through an indirect angle as it was, so I decided to cut a scallop out of the support plate, bringing the cam and link combination more in line. While I was at it, I also set the 8mm hole at the far end for the support plate pivot point. Mind you, I opted for the drill press for doing this bit because holding it and drilling it in the mill was a bit problematic. I used jacks and the tallest milling vise I have to hold it on the drill. Even then, the extended sections still dangled off the sides while I drilled it. I made a small back-facing tool to clean up the area on the underside to hold the flat spring when it's finally bolted on. As you can see, it worked quite well, but I should have used a thin-walled sleeve to make it a little more rigid while it was rotating. The base plate needs 2 slots cutting into it to be able to clamp it to a table, mainly the one on the clocks and cutter grinder. It also needs 3 holes, 2 at 8mm and 1 at 6mm, each to be done in their own time. I've put some setting lines on the base plate to be sure that I've got the support plate in the right spot every time. And after popping a punch mark through the 8mm hole of the pivot point, I made sure off camera that it was well marked. Doing this allowed me to rough scribe the guide slot, ensuring that nothing got in the way before turning it over and using a bit of brass rod with a centre mark in it to fill the 8mm hole. I used it to scribe a very light curved slot and then marked out 5 punch marks. The holes were drilled on the drill press, but the slot was teased out using a 6mm fettling tool while remaining within the marked lines. To finish, I used a very fine file to clean everything up. You can see here that I've changed the cam position a couple of times. Look at the bullet marks. I'm about to set the stop pin position using a 6mm punch. This is the punch tool I used earlier. The 3 holes, 2 8 and 1 6mm, were done off camera before putting the base plate back on the milling machine. I used a 14mm roughing end mill to do both plunge cuts and then slotted them at full depth. That's all for part 1. There's plenty more to come in the next video. Thanks for watching. Bye for now.